Now that we've seen how to convert octal and hexadecimal to decimal, let's use our multiplication method to convert from binary, base 2, to decimal, base 10. So the formula is the same as before. Given a binary number, let's say the digits are WX, Y, Z. My example has 4 digits, but this works for any number of digits. The first thing we're going to do, step 1, is we're going to write out the digits with placeholder subscripts. So what does that mean? We've got the number WXYZ. The subscript is the number right at the foot of this digit, and we're going to start at 0 in the least significant bit and increase as we move to the left. So this will have a subscript of 1, 2, and 3. Okay, so we just write that out. And then step 2 is we're going to multiply each digit by 2 raised to the subscript. Multiply WXYZ by 2 raised to the subscript. Okay, so we have to do this one by one. It looks like this. Here's our binary number. Here are our subscripts. And I'm going to take this digit. Remember, it's either going to be a 0 or a 1. Z. I'm going to multiply by 2 raised to the 0. And 2 because binary is a base 2 number, and 0 because 0 is the subscript on the Z. And then I'm going to take, the next one is Y. Y times 2 to the first because 1 is a subscript on Y. Then we do X times 2 to the second because 2 is a subscript on X. And then finally, W gets multiplied by 2 to the third. And then the last step in this method, step 3, is we just add up all of these products, whatever that is, whatever that is, whatever that is, whatever that is. Add up all the products to get the conversion to decimal, to base 10. Okay, so let's see a couple of examples. Let's do one small, easy one, and then one more complicated one. So for example 1, let's convert binary 101 to base 2 to decimal. Okay, the first step, we write out the digits of our binary number with subscripts with placeholders. And then we take this digit, so the first 1 here, multiply it by 2 to the 0 because 0 is a subscript on the 1. Then we take the next digit, 0, multiply by 2 to the first because 1 is a subscript on the 0. And then lastly, this 1 in the most significant bit position gets multiplied by 2 raised to the second power. All right, so this gives us 1, this gives us 0 because 0 times anything is 0, and this gives us 4. So our last step is we just add up all these products straight down and we get 5. So therefore, 101 in binary is equal to 5 in decimal. Okay, great. So let's do a second example. What about converting binary 10110110 to decimal? All right, so first step, we write out a binary number 01000110 with placeholder subscripts starting at 0, the least significant bit, and getting larger as we move to the left. 3, 4, 5, 6, 7. Okay, great. So then we take this digit is 0. We multiply by 2 to the 0 because 0 is a subscript on the first 0. Then we do 1 times 2 to the first. This digit is a 1, so we do 1 times 2 to the second because it has a subscript of 2. This 0 has a subscript of 3, so we take the 0 and multiply by 2 to the 3. This 1 has a subscript of 4, 1 times 2 to the 4th. This one here has a subscript of 5, so we do 1 times 2 to the 5th. This 0 has a subscript of 6, so we multiply by 2 to the 6th. And this 1 has a subscript of 7. Okay, great. So then the products are, this gives us a 0, this gives us a 2, this gives us a 4, this gives us a 0, this gives us a 16, this is 32, this is 0, and this is 128. So the last step of our method is we just add all these products straight down. So the sum of all these is 182. Therefore, 10110110 in binary is equal to 182 in decimal. Or with our subscript notation, it's 0110 base 2 is equal to 182 base 10.